Polynomials on infinite intervals. Let's suppose we have a polynomial function here, and we have an interval for negative infinity to infinity, and it wants me to find the absolute max and absolute mins, and I guess where they occur we have. Yes, and where they occur. Alright, so what I'm going to do for a polynomial function on this infinite interval is I'm going to think about the end behavior of a polynomial. Remember, if the highest exponent on x is an even exponent, your polynomial is going to go up and up on the far ends, or down and down on the far ends, right? Remember, if this would have been an odd number like 3, your polynomial will go different directions on the far ends. Alright, and how do we know this one? Okay, we know it either goes up and up on the far ends, or down and down on the far ends. And what tells us if it's going to go up or to down is this leading coefficient. If it's positive, you have this case. If the leading coefficient is negative, you have that case. All right, my leading coefficient is 4, so that's positive. So I have this case, up on the far left, up on the far right. If you're rusty on that stuff, go back and look at your college algebra notes. So this polynomial function is going to do something like this on the far ends, okay? Now, I don't know what happens in between here yet, okay? But if this happens, up on the far left, up on the far right, will it have an absolute max? No, it will not, because it'll go up forever. So we're going to put no absolute max, because far end behavior, I could say, far end behavior. All right, but my function is going to come down and do whatever it does, okay? So we'll have an absolute min here. So how do we go about finding our absolute min? Well, let me ask you this. No matter what it does here, where's the absolute min going to occur? It's going to occur at the critical points. So let's find our critical points. So to find our critical points, what do? Find my derivative first of all. So f prime of x is equal to 8x minus 12. Now find out where this derivative is equal to 0 and where it's undefined. So let's find out where it's equal to 0 by setting it equal to 0. And it's not going to be undefined anywhere because it's a polynomial. So we get 8x is equal to 12, and if we divide both sides by 8, what do we get? We get 12 eighths. But we could say that's also what? 3 halves, right? So that's my only critical point at 3 halves. So that must mean that's going to be where my minimum occurs. Now that's where my minimum occurs. But what is my minimum value? How do you find that? That's the output of this function f when you sub in 3 halves. So f at 3 halves will be equal to 4 times 3 halves squared minus 12 times 3 halves plus 10. And then calculate that. You could put it in your calculator now. It really doesn't matter, okay? So you get 4, and you get what? 9/4 minus 18 plus 10. So that gives you what? 9 minus 18 plus 10. So that will give you a what? 1. So you have an absolute min of what? Of 1. And it occurs where? Occurs at, what's the x coordinate? 3 halves. And what do we say about the absolute max? We'll just put that here. No absolute max for this function. Alright, so it seems to be easier for a polynomial, okay? Now, let's look at our last example here. Absolute extrema on open intervals from A to B. And for this example, we're going to look at an open interval instead of a closed interval, and we're going to look at a rational function. Alright, so this example has find any absolute extrema on the interval, state where they occur. We have f of x is equal to x squared plus 4 over x plus 1, and they tell us to look on the interval from -5 to -1. Now, how do I know that this is an open interval? Well, because of the parentheses instead of brackets here, okay? So what we're doing really is we're looking at a coordinate plane we could think of, and we're looking between -5 and -1. So we're looking between -5 and -1 in this area right here for any absolute extrema, but not including -5, not including -1. Now, what did you learn in college algebra about these rational functions? They can have vertical asymptotes, right? And how do you find a vertical asymptote? After you try simplifying, this one cannot be simplified. It's where your denominator is equal to 0. So where will x plus 1 equal to 0 when x is -1, right? So at an x value -1, I'm going to have a vertical asymptote here. X is equal to -1. Sloppy right there. Try to redraw that a little neater. Alright, so that's -1 right there. And we add this. So what happens to those vertical asymptotes? That's where your graph approaches infinity, or where your graph approaches negative infinity, right? Now let's think about this for a second. If my graph would do like this, then I'd have no absolute max on that interval because it goes up forever. If my graph would do this, then I'd have no absolute min because it would go down forever. Well, let's see what happens. Let's look at the behavior of my graph as I approach that value of -1. And in fact, let's look at what happens as I approach -1 from this direction, from the left. So let's look at the limit as x approaches -1 from the left of my function x squared plus 4 over x plus 1. Well, what does the top go towards? Well, substituting -1 here, I'll get -1 squared is 1 plus 4, and it goes towards 5, right? So the top goes towards 5. Top approaches 5. What does the bottom approach now? The bottom approaches 0, right? As x approaches -1 from the left. But if I'm approaching -1 from the left, put this right here where you can see a little better. If I'm approaching -1 from the left, I'm looking at values of like -1.5, -1.2, -1.1, -1.01. So what happens if I take any one of those values like -1.2, -1.01, and I add 1 to it? I'm really going to get a negative number, right? That goes towards 0. So what's a positive divided by a negative? It's going to be a negative. And what happens if the top stays fixed and the bottom gets smaller and smaller as we go towards infinity? So if the limit is negative infinity as I approach -1 from the left, as I approach -1 from the left, if my limit's negative infinity, my graph looks like that, right? So right away I could say no absolute minimum value on this one. Alright, but I'm probably going to have an absolute max here, okay? So how do I find my absolute max? Well, we could say it's going to occur at a critical point, right? So let's find the critical points. F prime of x is equal to, remember this is quotient rule, denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So that gives me 2x squared plus 2x minus x squared minus 4 all over x plus 1 quantity squared here. Well, let's combine some like terms. 2x squared negative x squared gives me just an x squared plus 2x minus 4 all over x plus 1 quantity squared. Now what is that? That's f prime of x, right? To find the critical numbers, set this equal to 0 and find where it's undefined. All right, so let's set this equal to 0, x squared plus 2x minus 4 over x plus 1 squared. Let's set that equal to 0, set my derivative equal to 0, and find where my derivative is undefined. It's going to be undefined when this bottom, or my denominator, is equal to 0, right? Let's solve this one real quick. X plus 1 is equal to 0 if I take the square root. So what do we have? X is equal to negative 1. All right, let's evaluate, or let's solve this. Let's multiply both sides by the LCD. So x squared plus 2x minus 4 is equal to 0. Now we have a quadratic equation. I could try to factor, but I'm not going to get anywhere. So if I can't factor this quadratic equation, I'm going to use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, let's clean this up. So x is equal to negative 2 plus or minus the square root of 4 minus, or plus I should say, 16 over 2. So x is equal to negative 2 plus or minus the square root of 20 over 2. So that means x is equal to negative 2 plus or minus, isn't this 4 times 5? So I have 2 square roots of 5 over 2. So that means x is equal to negative 2 over 2 plus or minus 2 square roots of 5 over 2. Now you can break this down different ways. I just chose to do it negative 2 over 2 plus or minus square root of 2 over 5, or square root of 2 times square root of 5 over 2. So that gives me negative 1 plus or minus the square root of 5, right? So what are my critical points? Critical points. X is equal to negative 1. X is equal to negative 1 minus the square root of 5 is one case here. The other case is x is equal to negative 1 plus the square root of 5. Now let's look at all these critical points and determine if they all lie within this interval or not. Because we're only looking within this interval. Negative 1 does not lie in this interval, because why? This goes up to negative 1 but does not include it, right? So I've got to cross that one out. How about negative 1 minus the square root of 5? Does that fall in that interval? Well, you could take your calculator and see what the decimal is of that. Or you could say, okay, this is slightly bigger than the square root of 4. Square root of 4 is 2, so slightly bigger than 2. So what's negative 1 minus 2 point something? Negative 3 point something. Is negative 3 point something lie in this interval? Yes. So I keep this one. All right, again, square root of 5 is a little larger than the square root of 4. Square root of 4 is 2, right? So square root of 5 will be 2 point something. What's negative 1 plus 2 point something? 1 point something, positive 1 point something. Does that fall in that interval? No, so we cross that one out as well. So my only critical point is this one right here. Now what do I want to do? I want to find what? The actual max value. We said we had no absolute min, so let's find the absolute max value. Alright, so my absolute max. What I'm going to do is I'm going to evaluate my original function f at negative 1 minus square root of 5. Now it's not pretty, but that's what I have to use. So up here, instead of x squared, I'm going to have negative 1 minus square root of 5 squared plus 4. Instead of x plus 1, I'll have negative 1 minus square root of 5 plus 1. All right, so what does this give me if I square this binomial? Square the first term, you get 1. Multiply these two terms and double them, you get 2 square roots of 5. And square your last term, you get plus 5. Then we have our plus 4. All over 1 minus 1 is 0, so I have negative square root of 5 at the bottom. And let's keep doing the math here. We'll get 1 plus 5 is 6, plus 4 is 10, plus 2 square roots of 5 over negative square root of 5, right? Now we can break this up. 10 over negative square root of 5 plus 2 square roots of 5 over negative square root of 5. So 10 over negative square root of 5 plus 2 square roots of 5 over negative square root of 5. So that gives me negative 10 over square root of 5 minus 2, right? Now let me go ahead and rationalize this. I can't remember if Wiley is going to take the answer if it's not rationalized. If it will, then this is fine, okay? But I'm going to go ahead and rationalize. I'm going to multiply by the square root of 5 over square root of 5, and that gives me negative 10 square roots of 5 over 5 minus 2, or we get, what, negative 2 square roots of 5 minus 2. Let me make sure I'm still in camera view here. Yeah, sure am. All right, so what is that? That is the output of that function when I input this number, right? So what did we say we're going to have there? An absolute max, right? Absolute max of what? Of this output, negative 2 square roots of 5 minus 2, and it occurs at x is equal to what value did I input? Negative 1 minus square root of 5. And we said no absolute min. Now, I want to check something real quick, okay? Let's think about this for a second. We said from negative 1 to negative 5, and we said my function was going to do what? Like this right here. But what happens at the end with 5? Does it do something like this and then come back down, or what, okay? So technically, maybe I need to do this. Limit as x approaches negative 5 from the right of my function, x squared plus 4 over x plus 1. Well, what does that give me? That gives me negative 5 squared plus 4 over negative 5 plus 1. So that gives me 25 plus 4, 29 over negative 4, or negative 4 over, negative 29 over 4. So it approaches some number like down here, negative 29 over 4, right? It doesn't go to infinity, it doesn't go to negative infinity or anything like that. Remember, if it goes to infinity, what? Then I wouldn't have an absolute max. So this appears to be